So like a distilled water doesn't have distilled compositions. It's usually just water, and water is usually made up of hydrogen, hydrogens, and oxygens, two type of elements. And the next question, so when you go from variable composition to the next question, is it a pure substance? So the question is asked, does more than one kind of atom make up this solution? And if the answer is yes, it would be an element. But in this case, two elements make up water, so it would be in a compound. If we take, for example, a wood through this process, it would we would ask the question, is it uniform? So we already answered that question, and we said wood is not uniform, so it would be under heterogeneous mixture. All right. Now let's move on to properties of matter. There are two properties of matter. There's a chemical property that we're going to cover in a little bit. So chemical properties describe the way a substance may change or react to form other substances. And the next one is the number two, physical properties. These can be observed without changing the identity and composition of the substance. Example, color, odor, density, melting point, boiling point, and hardness. Um, so under physical properties, there's an extension. Um, Two other extensions. There's intensive property and extensive properties. Intensive properties such as temperature and melting points. So intensive properties do not depend on the amount of sample being examined. It's useful in chemistry because many intensive properties can be used to identify substances. Example would be boiling point, density, and melting point. Let me give you an example. Water at room temperature boils at 100 Celsius. So we can identify a liquid like water being water by boiling it, and if it boils at 100 Celsius, we would say it's water because it boiled at 100 Celsius, and that is under intensive properties. Extensive properties depend on amount of sample, example, mass and volume, relate to amount of substance present. Here, let's take a look at some physical properties. Here, RT stands for room temperature. So at room temperature, water is usually liquid. So, and if you compare water to hydrogen room temperature, hydrogen is usually gas. And if you also compare oxygen, oxygen element is also gas phase in room temperature. Boiling point, like I said earlier, of water is 100, and compared with these two are dramatically different. Another physical property is the density. We know that water is 100. Water's density is 100 grams per liter, and these two are also different dramatically. Um, so substances either go chemical change or physical change. So, for example, a physical change you can encounter with your everyday life. Let's say you have a piece of ice in a room temperature, and if you leave that piece of ice for a long time, it will be it will change phases from solid to liquid, and then eventually that liquid over time will evaporate and it will change to another phase like gas. Um, let's talk about chemical uh, properties. Chemical change or chemical, we also call it chemical reaction. So like a substance transform into a chemically different substance. Example, you see a chemical reaction in your life is when you drive a car. Mm, combustion gasoline with oxygen creates carbon dioxide and water. Also, let me give you another example of chemical reaction. Right here, we have hydrogen plus water and fire would give us water. Two important laws to remember in chemistry are first is the law of conservation of mass. So in chemical reaction, the mass is always the same before and after the reaction. What do I mean? If I start initially with 100 gram of these two elements, I should end up at the end of the reaction with 100 grams of um, whatever I have created. So mass does not disappear. It is always the same before and after the reaction. Another law to look at is the law of constant composition, or we sometimes call it law of definite proportion. So it says element composition of a compound is always the same. What do I mean by that? So this reaction right here, oxygen plus hydrogen and fire make water. This is similar to what we do in the lab and what nature does. There's no difference. This is what law of constant composition says. So chemistry deals with lots of solutions, liquid solutions, and one way to separate solutions, we have this apparatus here. It's a distillation apparatus, and it's separating the component of homogeneous mixtures. This method depends on the different abilities of substance to form gas. So this apparatus pretty much helps us separate homogeneous solutions. Like for example, if I have some water mixed with salt, um, and if I have this fire apparatus underneath it to make the water boil and eventually evaporate, it the water gases will eventually go through this tube, go to the right, passing this thermometer, and then through this cooling station. In this cooling station, the gas waters eventually lose their energy and become liquid, where they get collected in this little beaker here. At the end of the reaction, you're usually left with you're left with salt. Um, yeah, this is one way to separate a mixture, a homogeneous mixture.